Now, student, watch this video very carefully, because here I am not erasing all the thing. Okay, but timely I will erase some of the point. It is because now I am changing the name of coordination compound. Now the coordination compound is what? Tetracyanonucleate to anion. Earlier it was tetrachlorido, but now it is what? Tetracyano. Remember here, in the previous video, the ligand were Cl, that is chlorido, but now the ligand is changed. What? It become cyanido or cyano. Rest of the things are same, like nickel. Earlier there were nickel. The complex containing 4 ligands, I mean 4 coordination number. Again here 4 coordination number, and the complex is anionic. Again it is anionic. The number of anions were 2. Again here what? 2. That means the difference is only of ligand. Okay. Now the earlier ligand were what? Cl, weak field ligand, but now the ligand is Cn, it is strong field ligand. So how, if the two different type of ligand will approach to the same oxidation state having metal cation, then how do the properties, that is the hybridization state, the geometry and the magnetic property will change? This we have to observe. Therefore I am not erasing the complete part. Now how do I am getting change? You just consider it. Nickel, electronic number 28, the configuration will be same, there will be no change. Oxidation state, again there will be no change. It is because the Cn is having -1 charge, therefore again there will be no change in its oxidation state. It will remain same, that is 4 into -1. So X is equal to plus. Now the oxidation state of nickel, earlier were +2, again here is what? +2, but now the number of electron will be 26. 26 electron can be given in this form. The 2 electrons are removed from s orbital. Rest of the configuration is as it is. Now to hold 4 besides of Cl, I am making change here and I am writing the name of ligand given Cn. So to hold 4 Cn, okay, ligands lone pairs electron, nickel +2 must avail 4 vacant orbitals of equal energy. So 4 vacant orbitals will hybridize. As now here we have to change, besides of Cl, we have to write what? As Cn is, besides of weak ligand field, you to write here what? Strong field ligand. So is unable to, we have to write what? Able to. Okay, here is a connection. Able to pair up unpaired orbitals. So what? Here we have to write something. So this line is completely getting changed. So two unpaired n-1 d orbitals electron will pair up. Will what? Pair up. So new configuration will be that means what? Now we have to change the configuration. So I am erasing the complete portion, okay, of here. So now how it will be? Ni +2, here what? Argon 18, and then here what? D 1 2 3 4, and there is what? S, and there are what? 3 p orbitals. Now the pairing will take place, that is this orbital is getting paired up with the 4th d orbital. Thus the configuration will become, that was earlier paired, that was earlier paired, that was earlier paired, and this is what? Newly paired orbital. But now the 1 2 3 orbitals are vacant, completely vacant. So now there will be what? There will be D, this is S, this is what? P2. So now the structure become DsP2, that is what? You can say square planar. Okay. Now the orbital will be what? Diamagnetic. It is because there are completely filled orbitals and therefore the orbitals become what? Diamagnetic in nature. So student, in this way we can solve the question. This is actually student in NCERT book. The two questions which I explained in by taking the help of two videos are given in a single question. The question in the form of draw the structure of NiCN4, which type of complexes is there, what is the hybridization state, geometry and magnetic property of NiCN4 to anion and NiCl4 to anion. That is the comparative study is given, but in this board it is not possible to divide it into two parts. Therefore, I took the help of two videos. You can see the previous video and then again you can watch this video and then you can find how the comparison, that is the differences, develops in these two compounds. Although these two compounds having the same metal cation, having the same number of ligand, only the nature of ligands are different. One belongs to weak field ligand, one belongs to strong field ligand.